Good morning, good afternoon, good evening, wherever you are. I hope you're doing great. What we're going to go over today deals with rotations, primarily within the coordinate plane, but we're also going to be looking at constructing a rotation. I'll show you that first off. But I really want to make sure that you guys know how to identify what a figure will look like if it's rotated within the coordinate plane. A lot of you on an ACT or an OGT, not an OGT, I shouldn't say that. We're no longer using OGTs, but the ACT and the PARCC test, if you can just visualize whereabouts on the coordinate plane the figure will be rotated to, you don't even have to know how to do particularly the rotation itself. If you can just visualize it, you can probably get the problem right without a whole lot of effort. So we'll talk about that in a little bit. Key terms you're going to need to know for today, you have to know what a rotation is. Okay? A rotation is a turn. Okay, so if you're sitting in your desk and you turn to talk to your neighbor, if they're in the next row across from you, but in the same seat, all right, you're going to turn probably 90 degrees. Okay, that would be a counterclockwise turn if you're turning to your left, a clockwise turn if you're turning to your right. And so, clockwise turn, if we start at 12 o'clock and go with the clock, okay, that's a clockwise turn. Counterclockwise, start at 12 o'clock, go against the clock. Obviously, that's a counterclockwise turn. So, again, it's going to be important that you are able to visualize what's occurring within the problem. About a point called the center of rotation. Okay? And I'll show you the center of rotation just in a second. So, how does this all play out? Well, part of visualizing what's occurring is being able to construct it, okay, accurately. And so all of you should have a compass, a protractor, and a ruler that you can work with here. And here's what I'm going to do. I'm going to place my ruler. It's going to get kind of busy here, so I hope it makes sense to you. Place my ruler on the center of rotation. Now the center of rotation right here is going to be point C. And we're going to rotate this triangle 100 degrees counterclockwise. Now, counterclockwise is against the clock, so it's going to be moving in this direction over here. Now, you got to picture 100 degrees is just slightly greater than 90, so we're looking at somewhere probably right about in here is where point C is going to lie, somewhere in there, okay? So to visualize, to accurately see what's going on, I'm going to go ahead and put in a dotted line right here, okay? And then I'm going to bring my protractor down here, and I'm going to place the point right there on the center of rotation, and I'm going to rotate it over till I'm at point C, or what is that, point O right there. And I'm going to take my straight edge. Now you're going to have an easier time of this than I will. Can I get on this? Okay. I'm going to take this straight edge here, if I can move it, and I'm going to place a point. Let's see here, move it up here. There we go. I'm going to place it right there. And I'm going to move my straight edge so that I can match up with the 100 degrees right here. Now notice there's 90. Okay, here's 100 degrees. Okay, it's not going to match up right on there like I'd like it to. Okay, we're going to get as close as we possibly can there. And I'm just going to make a dotted line on that. Okay, now what we've basically done here is we've rotated this right here. I don't need this to be that big. Make that a little smaller. I'm going to rotate this. This is 100 degrees right here. Okay. Now, I'm going to continue to do the same thing from the other 3 points. So I want to encourage you guys, you can follow me as I do this up here, but you can probably do it faster on your paper than I can talk you through it. So go ahead and take this line right here. There's 100 degree, or my baseline right there. And if I can pull this, goodness. Okay. And I'm going to put it right on my center. And I'm going to find 100 degrees from this line right here. Oh, that's not on my center, is it? There it is. 100 degrees. Right there. Okay. So I'm going to place this on the center, and I'm going to rotate this over 80, 90, 100 right there. Oh, A little too far. Okay, and we're just going to go ahead and that right there. Okay, so as you look at that, this, starting from this point right here, is a 100-degree rotation right there, slightly greater than 90. Okay. Now from there, like I said, we're going to do the same thing from the last point. So okay, and I'll take my protractor down here, place it right on the center. Oh, kind of blurry. There's so many lines there. I hope it's not confusing you guys. Okay, so I've got my 0 degree right on that, and I'm going to rotate that 100 degrees. There's a 100-degree mark, so I'll take this and let's place this guy right there and rotate this 100 degrees. Oh, let's see here. 80, 90, 100 degrees. Okay, move that off. All right, actually we can get rid of that guy. Okay, and this point from here to here is 100 degrees as well. Okay, so all of those have been rotated, those lines are slightly greater than 90, they're 100 degrees. Now, the question then will be is, how do I find exactly where point O is going to lie on this line right here? Where does point L lie on this line right here? Okay, and where does point B lie on this line right here? Okay, how do we figure that out? Well, here's what you're going to do. You're going to take your compass here, and we are going to measure the length of O. And then we're going to rotate it over here and place it on the line that corresponds with the O. So this line goes here to here, so I'm going to place that there. And I'm going to put O prime for that part right there. Okay, so this is O prime. That's where O is moved, if it's moved 100 degrees counterclockwise. I'm going to do the same thing with the other two. I'm going to go ahead and measure the length from C to L and transfer that over here. And this point right here is L prime. And then for B, just slightly greater. And that is point B. Okay, so now I can get rid of that guy, my compass, and just connect all the points now. Okay, and there you go. We have these two triangles right here. They should be completely congruent to each other, and they should have a 90-degree or 100-degree rotation from one point to the other. All right. Now you can always double check what you did by using either a straight edge, measuring the lengths to see if they're the same, or you could use your compass to make sure that they are the same. But again, actually, let's go ahead and test it here, because I'm not sure how accurate my drawing there looks right now. See how accurate I was. Okay, so we've got that length. Is that the same as this length here? Yeah, I'm off by a smidge there, but that's probably because the board length. You saw I couldn't be real accurate with the angle measurements. If I go ahead and measure OB, let's see how accurate I was with that. Okay, so there's the length of OB. If I move that over to O to B, okay, again, I'm off by just a smidge, and it's probably due to the board's lack of accuracy than anything else. But that's how you go ahead and rotate a figure through construction right there. Okay, so you should be a lot more accurate than me, because you don't have to deal with the technology discrepancies that I have. So anyways, sorry that it took so long, but here we go. Next thing we're going to do, let's get rid of these guys. We won't need them anymore. Actually, I might keep that guy up, my ruler. Next thing we're going to do is we are going to discover what takes place within the coordinate plane when we do a rotation. Okay? So the first thing we're going to look at, on your paper, we should have, actually, I should have saved it. All right, sorry about that pause for a quick second there. I wanted to make sure that I had the correct document up here. You noticed on the previous document I didn't have the triangles drawn in. Now I've got them drawn in and we're ready to go. So what I want us to do, first of all, if we're going from figure A to figure B, this is figure A, B, C, and D, okay? So if we're going from figure A to figure B, how many degrees do you believe it's been rotated and in what direction? Well, first of all, if we classify from figure A to figure B, we're going counterclockwise. We are going against the clock. And so I want to put up here counterclockwise. Okay? And it's actually a 90-degree rotation. Now I'll show you why it's 90-degree rotation. If you take a look at the ordered pair, if I'm going to go, if I want to know the slope from this point origin to, let's say, y, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. So the slope from here to here is a rise of 8 and a run of 4. Now, both those are positive, and so we have a slope of 2 over 1 if you want to go ahead and mark it that way. Now, the slope from y, the origin to y prime is going to be up 1, 2, 3, 4, and a run of 1, 2, 3, 4, 5, 6, 7, 8. Now this is up 4 and left 8, so therefore this slope right here has a rise of 4, a run of negative 8, which becomes a negative 1/2 slope. Now this takes you back to the first quarter this year when we were talking about slopes of parallel and perpendicular lines. Negative 1/2, positive 2 over 1, you see that they're the negative reciprocals of each other. So therefore, this angle right here has to be a right angle. As a result of that angle being a right angle, the rotation is 90 degrees, and that's how we get 90 degrees counterclockwise. Now, something else that you should probably think about is this. I'll go ahead and draw on this one y triple prime to that point, which I think you see here that it's 90 degrees that way. And if I draw from y to y double prime, okay, this is going to be 180 degrees down in this third quadrant down there. And so, let's see here. Oh, where I was going with that. You can classify this as a 90-degree counterclockwise rotation, or this could be a 90, 180, 270-degree, that'd be clockwise rotation. So you want to make sure you have that down there. These both are the same. Clockwise and 90 degree, 270 degrees clockwise and 90 degrees counterclockwise. It's going to be in the exact same spot, okay, as long as it's around the origin. Actually, around any point, it's going to be in the same spot. Now, if you take a moment and go ahead and fill in the ordered pair for the x prime, y prime, and z prime, we see here that the x prime, actually let me clean this off a little bit so we can see this better. Okay, so A, C, D. Okay, so the x prime is over 1, 2, 3, up 1, 2, 3, 4, 5, 6. So negative 3, 6. Y prime, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4. Negative 8, 4. And then z prime, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6, 7, 8, 9. So negative 6, 9. Okay. Now as you look at that and compare all of those ordered pairs to the ordered pairs that we had originally, okay, these to these, what do you see is the rule basically? Well, the rule I hope you see, and I'll write this out like this. We start with our normal xy, and it leads us to Now we're switching the y to the first spot and making it negative, and the x remains the same. And so they're just switching, and the y is becoming negative. Okay, so if you're ever having to know when it goes around the origin what to do, you can always use that rule right there. Make the y value negative, put it first, and then put the x value second. Now the other thing that I like to put down here, when we do a 90-degree rotation, okay, I just like to go ahead and state what we already stated originally when we went from y to y prime. Okay, what do we do with these slopes? Well, we made them the opposite reciprocal slopes to make that right angle there. Okay, and so I'm just going to put down opposite reciprocal. Okay, and if you can remember that, it makes it really simple, because later on I'm going to have you graph figures on a certain point of rotation. So if we take a look at the next one, okay, we have figure A to figure C. Now, if you notice, if I were to draw a line from x to x double prime, it goes right through the origin there. Y to y double prime, z to z double prime. Okay, that last one I didn't draw very well, but all of them will pass through the origin in a straight line. Now, what degree is a straight line? It's 180 degrees. So one way to look at this is these are in opposite quadrants, so they have to be 180 degrees. Another way to look at it is it's going to form that straight line passing through the center of rotation. So as a result, let me go ahead and clear this off so we're looking at A and C now. This is a 180 degree rotation, and it's going to be clockwise or counterclockwise. It really doesn't matter. Either way you rotate it, if I turn halfway around in one direction, or I turn halfway around in the other direction, either way I end up in the same spot, and that's true with this as well. Now, if we take a look at the ordered pairs of x, y, x double prime, y double prime, and z double prime, x double prime is out here at 1, 2, 3, 4, 5, 6, down 1, 2, 3, so -6, -3. Okay, z prime is out here at -9, -1, 2, 3, 4, 5, 6. Okay, now if we look at the, that was z, sorry, undo both those. I said -9, -6, okay. Now if we look at the comparison between what we have here and what we have here, you notice that both of them become negative. Or another way of saying it is both become the complete opposite of what they already were. And so we can take a guess. Is this going to be at -4, -8? Let's see. This is y, so -4, 1, 2, 3, 4, -8, 1, 2, 3, 4, 5, 6, 7, 8. Oh, there it is. Okay, so that's actually the rule when going around the origin at 180 degree rotation is going to be the original point, and then you are going to have sorry, not -y, -x. Comma -y. Okay, it's just going to be that same value, just the opposite. Now, what I made as another sort of rule that I think is going to be key, if you were to count this to get to x over 1, 2, 3, 4, 5, 6, 1, 2, 3. So actually I should probably do slope. Rise of 3, run of 6. Okay, 3, 6. If I keep the same in the opposite direction, rise of 3, run of 6, 1, 2, 3, 4, 5, 6. You get the exact same location, that same point. Okay? And so I just said this, equal slope opposite side of center of rotation. Okay, so you just keep going with that same slope beyond the center of rotation, and you'll eventually hit the next point that you want to plot. Okay. All right, now let's clear that off, and let's go down just a smidge. Can I get good enough? Okay, we can see that without losing our picture here. Now we're going to go from A to D. Okay. Now I hope that to this point you're starting to figure out what the rotational, what it's going to be. Okay. This one, if I'm rotating from the first quadrant to the fourth quadrant, I'm rotating it clockwise this time. And as I showed previously, if we're going from X to X double prime, this is going to be 90 degrees, but it's going to be in a clockwise manner. So as opposed to the first set that was 90 degrees counterclockwise, this is going to be 90 degrees clockwise. Or, as we already mentioned, if this is 90 degrees, then this portion over here has to be 270 to make 360. So we could also say 270 degrees counterclockwise. Okay? So, with that being said, if we fill in the ordered pairs here, get rid of this. Okay? The ordered pairs we have for X 1, 2, 3, 1, 2, 3, 4, 5, 6. So 3, negative 6. Okay. And let's do one more. Let's do Y. This will be at 8, negative 1, 2, 3, 4. 8, negative 4. Okay. Now if you look at what we have previously over here, we are switching and we're making the Y value negative. So if we switch 6, 9, make the Y value negative right there. Okay. Let's see if that works. 6, negative 9. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good deal. Okay. So again, you can use that rule when you're doing a 90-degree clockwise rotation. Actually, I'll wait to do that with this one, X comma Y, and it's going to lead us to, what did I say? We're going to switch those two. And we're going to make the Y value negative, the second value negative. Okay? And so that would be the rule that you could follow. Now, I'm going to go ahead and say this, just like before. When you do a 90-degree rotation, you can use the opposite reciprocal slope. Reciprocal slope to the point of rotation. Okay. Now, again, what do I mean by that? Hopefully this is making sense. Excuse me. If I'm going to go from X to X double prime, I know that if I'm rotating at 90 degrees about the origin, I'm going to go from the first quadrant to the fourth quadrant. I have to be able to visualize this to make this rule down here make sense. But if I do the slope, rise over run, okay, we have up 3, we have right, 1, 2, 3, 4, 5, 6, that's what I thought, 6. So the rise over the run, both are positive, become 1/2, okay? Now from there, I want to do the negative reciprocal, so the negative reciprocal of this would be negative 2 over 1, okay? And if we do that, negative 2 over 1, or should I say negative 3 over 6. Let's see here. Switch that. Negative 6 over 3. I can go 3, 1, 2, 3, and negative 6. 1, 2, 3, 4, 5, 6. Okay? So 3, negative 6. And again, that slope right there, if you wanted to count it, rise of 1, run of 2, rise of 1, run of 2, rise of 1, run of 2. You have 3 of those right there. You could always do down 2 over 1, down 2 over 1, down 2 over 1. Again, it's the same number, but it's the opposite of what we have. And so we're reaching that point. So I'm not sure I communicated that last part very clearly, but I hope maybe it triggered something for some of you guys that you can be able to figure out where those points will lie. All right, so from there, homework for tonight is to go ahead and complete the rest of those practice problems on your worksheet there. And tomorrow I will be checking those. Now, one thing I want to bring to your attention, when you look at the practice there, it says roughly sketch the figure under the given rotation for numbers 1 through 4. I'm not expecting you to accurately, like real accurately, be able to sketch these out. I'm not expecting you to go ahead and construct them. But what I am expecting you to do is, to the best of your ability, figure out where approximately it would lie. For example, number 1 might be kind of difficult, okay? But number 2, I think most of you could do that one to a high degree. It should be pretty easy. Number 3, I would think that you guys would be able to do that one to a pretty high degree. And number 4, that one should be able to be done to a pretty high degree as far as figuring out where the new figure will lie. Okay, now tomorrow I will show you where it will lie through construction, but I want you to be able to do that. If you look at numbers 5, 6, and 7 on the back side of your paper there, I'd like you to try and take a guess as to what the degree of rotation and the direction of rotation will have to be. And so make sure you're choosing the same points on the figures, sort of like when I did up here when I chose X, and I chose X down here. That's how we figure out the angle of rotation. Make sure you do that for numbers 5, 6, and 7. For numbers 8 and 9 on your paper there, you've got, around the origin there that you're going to try to figure out what that figure is going to be. You should be able to use the graph or the chart that we just came up with, those rules that we did in class. And numbers 10, also you should be able to use your chart for that. And number 11, that one's a challenge one. I want to see if you can do that one as well. So good luck to you. I apologize I couldn't be here today, but wish you the best. And if you have any questions, I'll be back later on this afternoon. I'll talk to you later. Good night.